Today we're going to find the electric field at point P inside a solid plastic sphere of charge. So I'm going to draw a plastic sphere that has the radius of 20 centimeters, and the distance from point P is 12 centimeters, and this is a plastic sphere with uniformly distributed charge, something like this. So it's uniformly charged and has a net charge of 8 microcoulombs. And to find the electric field of P, which is inside the plastic sphere of charge, we use Gauss's law. So to use Gauss's law, we need to draw a Gaussian surface that passes through point P, like this. And we could write out Gauss's law, which is the magnitude of E times the area vector cosine theta, the electric field vector, area vector equals Q enclosed charge, and it's over epsilon 0. So we don't know what the magnitude of E is, but we know that this Gaussian surface is perfectly symmetric because it is a circle. So if I were to draw the electric field vector like this, they would all have the same magnitude. So all the E fields would be the same. And we're also dealing with one surface, so this is only like one flux. Yeah. Okay, and for the area is from inside to outside. So from inside to outside like this is the area vector. And if we compare it to the electric field vector, you can see that theta is 0. The theta between them is 0 because they're perpendicular. And for the magnitude of the area, we write the area of a sphere, which is 4 pi r squared. And we already said that theta is 0, so it's cosine 0 degrees. Now for the Q enclosed charge, this whole sphere is uniformly distributed, so the enclosed charge is not equal to the total charge, which is 8.0 microcoulombs. So what we need to do is we need to take the charge density, which is Q total over the volume of the sphere. So that is 8.0 times 10 to the negative 6 over the volume of the sphere is 4 over 3 pi r cubed, and r is 0.2, which is from the 20 centimeters. And we multiply it with the volume of the Gaussian surface, which is 4 over 3 pi times 0.212 cubed, r cubed, which is the radius of the Gaussian surface. So if we do the total charge over the volume of the sphere, multiply that by the volume of the Gaussian surface, we get Q enclosed of that Gaussian surface, which is what we want, and that's over epsilon 0, which is 8.9 times 10 to the negative 12. And 4 pi r squared here is 4 pi, and r is 0.2 12 squared? Yes. Okay. And this is cosine of 0 is 1. So what we do is just solve. So these cancel out, and I will rewrite this as 8.0 times 10 to the negative 6, 0.12 cubed, and this goes to the bottom, 0.2 cubed times 8.9 times 10 to the negative 12. Move this to the other side by division, that is 4 pi 0.12 squared. And just put it in your calculator and you get the electric field at P is 1.1 times 10 to the 6 newtons per coulomb.